Good evening, everyone. Today, Munir and I will be going over the final milestone of the Advanced Machine Learning project, which is movie recommendation systems. So for the problem statement, we have an input matrix that has some movies and the ratings that the users have given to those movies. However, some of the ratings are missing, and we try to predict those ratings in order to give the user a recommendation based on them. So for the original model, it's divided into two main stages, the pre-training stage and the global and the fine-tuning stage. The pre-training stage actually gives us an output, but it's not fine-tuned, and then the fine-tuning stage improves the output. For the evaluation metrics, we'll be using the root mean squared error and the NDCG score, which are both mentioned in the paper. And here are the initial plots of the baseline model that we'll be comparing against later, and here are the results. So for the proposed model that we wrote about in the proposal, we thought of two updates, the ensemble learning approach, the bagging one to be specific, and the data augmentation. So for the data augmentation, a 10% increase is a good starting point to start from. And for the bagging method, we thought of training 4 models, each on a subset of the data around 80%, and it's a random sample. And then we average the results of all models and round the rating to the nearest number. So for the proposed updates for this milestone, the first one was to try the boosting method, and it's slightly similar to bagging, but not exactly. So in boosting, we train the models sequentially, and each model tries to correct the errors done by the previous model. So its main focus is to see the mistakes that the previous model has done and try to fix those, and then we get the prediction from the last model in the ensemble. However, the scores we have gotten weren't better than the baseline. They are slightly close to it, but not exactly. And we think the implementation might not be 100% correct, so we might try to improve it later. For the next update, Munir will be going over it, and then he will go over the final architecture that we have done and the results we have gotten. So for the poster, we have gone over all the important things. So an intro to the project, the dataset using the baseline model, the input-output format, the updates you have done, and the ones that were used in the final architecture, the results, conclusion, future work, and references. For the website, we have also done our requirements. We have written the problem statement, details about the dataset, input-output examples, state-of-the-art models for our application, the model from the literature and how it works, all the proposed updates we have done and some details about them, the results of the original and the final model, technical report, the conclusion, future work, and our references.
The second approach we have done in the final milestone is the adaptive learning rate, where the learning rate we edit and modify while training. So by passing epochs, while the model converges to a specific number, the learning rate decrease or increase accordingly to keep the learning more accurate and get the best performance out of the training set. But as you can see, the results aren't really good, and it's not really an effective method, because there is a slight like not improvement, like it didn't improve in the dataset 100K. Moving on to the final model and choosing between all the 6 approaches and edits we have done and proposed in this project, we've chosen the attention mechanism, where it showed a slight improvement above the baseline model. So basically, what we have done is we added a self-attention layer right before the encoder, and then attention mechanism between the encoder and decoder with a single hidden layer, and then attention span of 5. We also increased the dropout rate to an 0.7, which is very high, but that we have done that to prevent overfitting. If we compare the results of the baseline model So this is mainly the result of the baseline model, and this is for the one with the attention mechanism. If you compared both results, we would find an improvement from that number 907 to 902, which is kind of slight improvement. However, we still competing with the state-of-the-art models, which is really outstanding. Also, there is an improvement in the NDCG rate. Um, this is all done in the 100K dataset. And here's a snippet from the code itself. So in conclusion, among all the edits we have done, so the green arrows are mainly the edits and approaches, and the black texted steps are mainly the one with are mainly the final edits in the final milestone. In conclusion, the self-attention mechanism won, and there is with no doubt the hyperparameter tuning did a huge impact for our model. If you wonder if we have any future work, yes, we do. And mainly one of them is to upload what we have done in Kaggle and see the results and how would we compete with the state-of-the-art models. Here's the contributions for each one, references. Let me go very quickly to the demo and run uh, if we chose a user and a movie, we can get easily um, the rating for the movie, which is 4.3. So 0 here means the movie is not rated yet. So if I would give this movie a rating, it would be 4.3 according to the model we have done. And also we've added an extra mile, which is predicting the top 10 movies for a single user, and we can also modify that. Thank you for the presentation.